C.S. Lewis here. It costs God nothing, so far as we know, to create nice things, but to convert rebellious wills. There's a little southern drawl came out a lot there. Wills cost him crucifixion. Let that resonate within your corazon. Okay? What did it cost God to create everything? But to convert our rebellious hearts, it cost him crucifixion. Good stuff. Super humbling to think about. Great. So brake linings, master cylinder operation, and different brake design. Okay, so this is a caliper, basic caliper. So you're going to rip one apart, actually in a nice way. Just a heads up, these are exposed to all the elements. So they are notorious for getting stuck. There's great ways to do this. In our lab, you're going to do it the safe way. You may have to do this on the O's and P's. So the best way to do this is, you're going to, if you have to remove the caliper, you're going to take the caliper, and when you do, you're going to loosen the nut on the top of the caliper, and then cap it, because it has brake fluid in it, right? We don't leak all over the floor, because then your instructor probably gets it right up and doesn't really have to about that. Okay, so side note there. Well, you're going to cap that line, and then you're going to take the caliper. You're going to put the caliper into a cage, little basket cage, and you're going to put compressed air, and you're going to send it facing away from you. Things you don't have to say, but you need to say, because the piston's going to fly out, and it normally has got a little bit of a sound to it, just, pop! And the piston will go flying out. Now you have the puck piston out of the caliper, okay? So you're going to put it into the same opening where the hydraulic fluid was going. It does have hydraulic fluid in it, okay? You will have to put compressed air. We run about 80 psi, and when you hit it, just as I said, make sure this is facing down. Okay? Things you shouldn't have to say, but you have to say. Okay? And it's going to send it. It will come flying out. Then you can inspect the inside of the caliper. Now it's super common on those calipers to get divots in there or little bitty lines. Okay? The piston is actually aluminum. So clean those up with just a little bit of Scotch-Brite. If there's a deep pitting, because it's old magnesium caliper, it may have to be changed. That's pretty common, okay? Because the brake gets so hot, it could cause the caliper itself to chip. If it's beyond repair and it's chipped out, you will have to replace that caliper, okay? But it is okay to take a little Scotch-Brite and buff those out, polish them up.
Today we're going to take apart a Cleveland brake. This is off a Cessna 150, but a lot of airplanes are very similar. Here we're measuring the brake disc and inspecting the disc. We took the tire off this wheel half, and before we do too much, I want to see what this brake's been through, and my brake disc looks pretty good.
All right, I'm going to pass around a couple of other examples here. Here is the expander tube on steroids. I couldn't find the small one, but this is the expander tube here. Inside is the tube. The tube blows up, and then it pushes on these asbestos pads here. Okay? The asbestos pads come out, and then they actually hit against the inside of the wheel rim. And they slow the wheel rim down, which then slows the aircraft down. Okay? So there's a series, and your side view, you can actually see the little pieces of metal plates that will flatten out as the expander tube gets 5606 pushing against it. And then it pushes up on these discs, pushes out, and then the brake pads are actually pretty chunky. I've got a couple of them right here inside the bag that you can take a side view of the brake pads themselves. Okay, this is super heavy. I had complaints, not from anyone particularly, that we're skipping them over. So I'm gonna take it down here to Jedediah. Here's how we're gonna roll, because people are getting skipped over. We're gonna go down this way, down to James, and then James back to Mr. Cheddar. Cheddar's gonna go all the way down to Miss Marcy. Marcy's gonna go back down to Heat Heights and back down that way. That way, everyone gets to see the toys, okay? All right, great. I just want to be, well, let me tell you something, life's not fair. Okay. Argue it all, be 5'6", whatever. All right, here is a cute version of a multi-disc. Okay, this is the cute version. I have a big version that's really cumbersome to pass around. All right, so the little tabs here lock into the wheel half, inside the wheel. I'm having to enunciate that for those northerners. Okay, so it rotates like this, and then notice the bolts. As you push the brake, so this side has the fluid in it, as you push it, it squeezes onto this plate, which is the stator, because it's stationary. Squeezes the rotating part, and you can even see the little linings in there. It's such a little cute one. This is off a 414 Alpha. 414 Alpha. So this is general aviation stuff, real life stuff, all the way up through bigger jets. Almost all of the newer modern aircraft are going to use this. This dissipates heat super good, and it stops at super short distance. Okay. All right. Everybody clear on the multi-disc? Alrighty. And then I have the 737 brake caliper here for you.
Where'd you get that?
Boeing. Yes. So this failed. Inside, what do you think these are for?
Trucks.
You betcha. A whole lot of, this is a caliper. Same thing as the little guy we passed around. This is this on steroids. Okay? This is a multi-disc, but still got stators and rotors, and it squeezes linings. And what's the benefit? What's the effect? You actually stop. Okay? Mega, mega, mega. It's actually relatively pretty stinking light for the size that it is. Now, I want you to get this vivid picture in your mind. Everybody see this. Burn it in your mind, Johnny. Burn it. Because the new ones use the same setup, but with worm gears. Actuators. So out of here, you'll have an actuated solenoid right here that will send out a worm gear out of this hole. And it's really coarse thread, so it comes out super quick to stop the aircraft. But it uses the same, almost exact same setup. It's wild looking. I'll show you what a video does. They did a 787 at 900,000 pounds, gross load, and stopped it. Just to show you how it worked, and it did like butter.
How does this, I know you're trying to explain this, I'm trying to understand in my mind how this actually works.
Okay, so you got a wheel. I've got the mega one. I don't really want to bring it in here, but I'll bring it in here. Maybe in the morning. So the wheel has little slots. It's groovy. Okay, groovy. The wheel is groovy. Okay, groovy, groovy. Okay, the wheel is groovy.
Lined up.
And these little tabs sit inside the wheel. And what does the wheel do when it touches the ground?
Turn.
It should spin, we hope. Okay? Unless it's a good gear, sorry. Stop.
You're not salty about that.
That's a little funny. That's a
No,
little
it's not.
Okay. All right, anyway, so it's spinning.
This
Wheel's
is spinning. This is stationary.
See this groovy?
Yeah, just those are spinning.
Yeah, these are spinning, okay? Because the caliper cannot spin. That's a no-no. It's floating, no spin. Okay, these are spinning. And then you see where the bolts are? These bolts, the ends are here.
Yep.
And so what happens is it says, ooh, let's squeeze those rotors. So it squeezes it, which is attached to the wheel. So then this floats it down. As it begins to rotate, it slows those little tabs down.
For servicing, you need to replace these.
You won't need to replace those. The linings are inside. See the little linings down in there?
The lines.
Yeah. Oh, what are you doing? It's a little weird. That one's not asbestos.
Thank
Hey,
you.
there's no insurance claim on that one. let's get back to, hey, you're all, you're all going to have to do a caliper. You're all gonna have to do a caliper, and so this is a basic single, puck, single piston caliper.
Good, a little bit of rust, but that's normal. It's a steel part. So now we've got the brake disc, or the brake caliper here. I'm going to take the bolts off, and I had the other pad, the two pads are bolted on, or the one pad's bolted on the outer pad. Take that off, and I'm going to do a little inspection here. Going to inspect these, and these linings actually don't look too bad. They've got some wear on them.
You notice how easy,
I'm looking at
how easy it came off the anchor bolts there? Okay, that's a common area for you to clean, okay? When we get to brakes this week, once you take your caliper off, go ahead and take a little Scotch-Brite and clean those anchor bolts, or what we call pins. I know Cleveland calls them pins, sometimes calls them anchor bolts. Anyway, clean those pins up where they actually should float. And that doesn't need to happen every annual or whatever, but it's a good practice just to get them good and clean so they'll actually float. The caliper will float a little bit better. It's pretty low maintenance.
Do you lubricate those?
Sometimes they tell you can do anti-seize on them. Here's the problem. Sometimes they'll tell you not to because they'll get dirt that sticks to the anti-seize because that's when it's touching the ground. So, once again, it's going to be based on manufacturer's manual. If in doubt, just clean them with a little Scotch-Brite. You can put a little grease on there if you wanted to. It's probably not a bad practice.
What about like a graphite powder or something that's dry?
Yes, I don't recall any in GA that says that. I haven't worked on airliners, so I'm not sure if even the big ones. I know Dean worked a couple years, two and a half years at United, but I'm not sure if they did lubricate.
the part that holds the axle mount for this. Now this has got a couple of grooves in it. I'm a little bit concerned about that, so I'll consult the overhaul manual over that. But not too bad. Here I'm pulling the inside lining out, and you can see underneath that's the piston. I'm going to measure this with the calipers, and my numbers are in the book, so I can check that. Here I'm looking at the overall condition of the caliper before I pull it apart. This caliper spent some time in the tank. Okay, here I'm going to take a little bit of compressed air. I'm going to turn my compressor down. I'm just going to give this just a little bit of a blast. Now, be careful because you can get hurt doing this. I turn my air compressor down and I blow the piston loose. And now we get a chance to inspect the piston, the cap.
Parts washer. He soaked it in the parts washer probably because it was so stuck.
And the caliper. And I want to see if there's anything broken here, any big scratches, galls. I pop the O-ring off with an O-ring tool. And the next thing is this thing's going to make another trip to the solvent tank. And I'm putting everything, there's a mineral spirits is the solvent that's in here, also known as Stoddard solvent. Taking my brush, I'm going to do a little bit of brushing and a little bit of cleaning, and we're going to get ready to start overhauling this brake assembly.
Not gonna overhaul it, you're gonna repair. Notice you better watch your phraseology there a little bit. Yeah, you're gonna repair the brake assembly. Somebody had a hand up? Mono Sarsen? You had a hand up? Sort of Latin for hand up, whatever. Okay. So this is typically what the caliper will look like. Sometimes it'll be on the top, sometimes it'll be on the bottom of the aircraft that you're working on, okay? Doesn't really matter. It's really about where it's mounted, okay? And the aircraft service manual will tell you how to mount this part. Okay? And it'll be mounted, well, all I have is a 4s. Okay, so here's your axle, and then it'll tell you how to mount it. So the older Cessnas, some of them will have, or even the Piper will have like the 6-bolt instead of the 4-bolt. But just imagine with me for a second, indulge me, okay? Indulge me. So, comes in here and then it bolts on, okay? Now it's bolted on there. This can stay, the tire can stay, and you can work on the caliper just like this. So, you would remove this line and cap it. Is there air in the hydraulic system now? Yes, there is, okay? If you don't cap it, there'll be a lot of air and no fluid in the system. Okay, at least on the right side. You have two black plate tie bolts. When you loosen that, you can either pull the lining up this way or like this. Don't just let it fall. Okay, it's either a cast aluminum or cast magnesium, they will break. Okay, and then pull that off and now you've got your caliper. Okay, everybody clear? All right. I do not like for them to hang. If you're working on the tire and you need to get the brake caliper out of the way, don't just let it hang. I hate that. I usually set a 4x4 or 6x6 block and just let it sit on there. I've watched some people put safety wire or zip ties around there. If this was a nice paint job, that would also damage it as well. So typically, that's why I've always gone to the 6x6 or 4x4 if I'm working on the tire to set the caliper on. Now, if once I take it off, I have rags there. I cap it with the right size cap. Now I'm going to send it to the solvent tank. Okay, I'm going to inspect it there. All right, everybody clear on this little setup here. Now I realize this is a 6-bolt on a 4-bolt, so just imagine this is 4 bolts on for the axle, so that it bolts on like that. Okay, that's where that came from. Everybody good? All right, that's all it rides for the Cleveland system. All right, same thing here with this guy. So if you're working on a Goodyear, which some of you might be working on a Goodyear, then it's going to go wrong way, off, like that. Okay. Then it's going to go like that. So if you're ever going to have to pull that, then you're going to have to pull the whole the wheel tire and then the whole bolt pattern. So it'll take more time. It'll obviously be jacked, and then you'll pull the axle to get to that one. Okay. Okay. So here's my end. Here's my end. You've already seen this picture. There's the lining. There's another lining here, back plate, and then pressure plate here. Okay? You do not have to take these dowels out. Please understand that. The anchor bolts you can just leave in. Okay? You don't usually see them damaged. Okay? You can just leave them in even while you're working on the caliper. On the bottom of it, sometimes on the top, Piper sometimes puts them up here, but we'll have this little bitty fitting, okay? Not this one. Everyone pay attention. Not the big one. The little one. It's a 1/4-inch wrench. Has a bleeder. It's a bleeder. So all you need to do is crack it loose. Have someone push in the brake, break it loose, and then you can bleed it. When you're redoing the caliper or basically inspecting the caliper, this will need to come out and cleaned out. It has a hole in it that picks up sludge sometimes. Okay? It will pick up sludge in the bottom of that bleeder, and you want to get that cleaned out so that you can bleed it more effectively. Okay? All right. I have a, yes sir.
When you're doing the top-down method, is he pumping on the brakes, or is he just holding?
He's holding the brakes. You're barely cracking it and then retightening it, and then he's letting off. Then he pumps the brakes back up. Pumps the brakes till they're firm. Hold it, crack it loose. I'll show you a video. I've got a generic video from someone, and then I have my own videos that I shot too. Yes.
How would you clean that bottom bleeder valve?
You can unscrew it like lefty-loosey all the way out when you have the caliper in the tank, and you can clean it out that way. Or once it's all the way out, you can hold it very tightly and hit it with compressed air, and it will go. Hopefully not the valve, but the dirt. All right, here's a generic video of a gentleman doing a lining installation. You all will have to remove linings, install linings, inspect linings, whether they're good or bad. Okay? Linings should never, ever, ever be loose. They should be tight, very tight.
Typically, rivets come with both these brake pads here, and we can see there's a
Yes. Yes, they should be tightly riveted to the plate. I've seen them, I've pulled them off before and the lining moved. Okay, all it's gonna do is crack the ceramic.
big gap there. We've already pressed our piston back into place, and we can see the inner pad is pretty substantially worn there. The outer pad, not quite so much. Looks like those sliding pins that normally this caliper would slide on and float. They call it a floating caliper design. Looks like that kind of bound up on us. Maybe we ran out of grease, and so the inner pad where the piston pushes out was wearing substantially more than the outer pad. So we're going to go ahead and take both those off and replace both of the linings. Our 7/16 inch wrench here, we're going to go ahead and break free both of these bolts. Should come free pretty easily. And there's not only the bolt, but also the washer that we'll have to hang on to.
Thinking about warm weather right now? Anyone else?
When it comes to AI, there's something big happening. The smallest things are creating.
All right, so we've got our one backing plate off here. We can see our two rivets. The rivets kind of folded over on the back side there. We're going to keep our backing plate and replace this liner that's partially worn. And then we can go ahead and pull out these two bolts here. Make sure you hang on to those washers. We'll just slide this guy right out. And that's what we have here. This is our brake assembly for pretty much any small general aviation aircraft, actually. This is the same on a 172, Piper Cherokee, most of the Piper products, most of the Cessna products, Diamond. Really all of them use the same design. 2 pins so it can slide back and forth, and then this piston comes out when you press on your brake pedal. This backing plate gets pressed out against the rotor. As that gets pressed against the rotor, this is bolted to the other side so that it actually squeezes from both sides, but it's only going to squeeze from both sides if these pins are well lubricated and it can slide and float back and forth properly. If they're not well lubricated, as it begins to bite, it's going to kind of bend down or get stuck in place there and get pushed and locked in kind of crooked there. And most of the force will come from the inside, not from both sides, so you'll get uneven wear like we have here. We've got a pretty thick pad on the outside, pretty thin on the inside. It's all the way down to the rivets just about, so it's definitely time to get replaced. So normally our piston would be pushed out quite a bit here. We've already pushed that back in with our C-clamp, so we would simply take a tool like this guy right here, take our C-clamp, open it up, put that on both sides there, and then go ahead and screw it in to push our piston back into place. As we're doing that, we could also go ahead and open up this bleeder valve here with a little wrench. And it's just about a, I believe that's a 3/16 wrench on this bleeder to open. As you push that piston back in, you could just push it back in and the hydraulic fluid or the 5606 would go back through the line and come out usually the top of the overflow at the reservoir at the pedals. However, any dirt and grease and grime that has gotten past your O-ring there would also be pushed back into your brake line system, and you really don't want to do that. So you could just break free this little bleeder valve here and let all the brake fluid just kind of leak out into the little receptacle there, squeeze it all out. You should be able to push this piston back in just with 2 thumbs. You don't even need the C-clamp really. Close that bleeder valve so you don't get any air in the system, and then go ahead and make sure you top off your brake reservoir at the master cylinder itself, and we'll show you how to do that right here. So that's our master cylinders, one on each pedal, behind each rudder pedal there, and that is what we're actually going to fill through that little screw there on the top. That's what we're going to fill our 5606 through. So we'll go ahead and top that off before we go ahead and press down the pedals and send more junk down through the brake line. We always want to make sure that master cylinder is topped off with 5606 so you don't introduce any air into your brake lines. So definitely a good thing to check and make sure it's always topped off. So to remove our linings from our backing plates, we're going to use this handy dandy tool here. And we got this tool from Aircraft Spruce. The part number is in the description below. So we're going to go ahead and take our other backing plate, repeat the same steps again. We're simply going to line up the flat side down on the tool and then put our little pin here and line that up on the center of the rivet. Want to be very careful, it's directly in the center. So we'll get it most of the way here and then take some time to go ahead and realign it, make sure we're dead on right in the center.
Rivet out, it's brass. It'll do it for you. Same tool that.
So we're right in the center there. It's hard to turn at first. A couple turns and then all of a sudden it's going to get easier. And there we go. Nice and easy all the way through. Go ahead and undo it now. And there we are. Our rivet's been pushed through the bottom of that tool. It's out of there. Our backing plate is loose from our lining, and we can go ahead and do our other one. All right, backing plate's free of all rivets. We could wire wheel it if we wanted to. Then you definitely have to corrosion exit. We're not actually going to wire wheel it. We're just going to wipe it down real good and put some corrosion X or LPS3, some sort of corrosion protectant on there. If you use corrosion X and some sort of corrosion preventative, these backing plates should last you the life of the aircraft, 10, 15, 20,000 hours, whatever it might be. They're not going to go bad. It's just the linings that get replaced every couple hundred hours. If it's with students, it might be every 50 or 100 hours even. If they're riding the brakes a lot, a private owner can usually go several hundred hours on a brake pad change. Now, it's not a bad idea to change the pads well before they're worn. And my main reason for saying that is as the pads wear out, that empty space is going to be taken up by this piston. And this piston is then going to be outside the caliper and exposed to the elements. It's going to get a lot of dirt and a lot of corrosion. And by the time you do change the pads 300 hours later and 6 years later in some cases for some owners that only fly 50 hours a year or even less, there might be so much corrosion on this piston it would have to be replaced because it would not go back into the caliper. They call this a cylinder rather than a caliper, but I call it a caliper, much like on a car. But this piston may have so much corrosion on the exterior of it that you wouldn't be able to push it back in, and oftentimes it may be so bad that you can't just clean it up with a little bit of fine sandpaper, or the A&P can't clean it up, so you have to buy a whole new assembly. And that's just not really worth delaying a brake pad change. These brake pads themselves are about $7 each for each lining, so 14 bucks to do a wheel. So $14 is a lot better than a $300-some assembly. So we'll go ahead and we'll take our brake linings here. We'll go ahead and drop our rivets into place. Typically rivets come with the linings. If not, these rivets are just about 15 cents each. You can buy a big pack of them fairly inexpensively. So we've got our rivets put into place there. You can see them sticking down the bottom of the lining. We'll go ahead, we'll do our backing plate for the inner side first. You can tell which side gets the backing plate on it by those dimples there, and also just the marks left from the years of use.
The head of the rivets should always be inside.
So we've got our two inserts in place. We'll go ahead and get our backing plate lined up in there.
So you have to change the tool, the setting on the tool. But it's
And it kind of helps. It sort of self-centers, but we want to make sure we're dead center on this when we push it all together. And again, it makes a huge difference if you have a vise handy to do this in, so you're not doing it freehand like we are right now. It makes it a lot harder to hold this thing. We'll go ahead and brace against the tire to make it easier on ourselves. And we're simply just turning until that rivet mushrooms, and we get a nice firm grip between it and the between the lining and the backing plate.
It should not be extremely hard. You don't have to dug it. It's just a slight tension to it.
Go ahead and undo that here. Take a look at our handiwork and see how that looks. And that looks like a pretty good fold over of the rivet. It's firmly attached. It's not going to go anywhere. We'll go ahead and do our other one and just repeat that step 3 more times, and this wheel will be re-riveted. Get our other guy in there. And it's important to talk about as we're doing this that if those holes don't line up exactly perfectly, you know, that they're maybe just a few millimeters off and you can't get the rivets through the other side, like we see here where they both come through nice and easy, everything lines up great, don't get a drill or a file and start making adjustments to make the stuff line up. These linings are only a couple bucks. Go buy the right ones. You just ordered the wrong ones. There's slight differences between Rapco and some of those Cleveland brake assemblies. So, you know, if you're not sure, just order one pad of Cleveland, one pad from Rapco. Take the brake assembly apart, let the aircraft be down for a few days, take it apart, test fit it, find out which one works, and then go ahead and order the 3 others from the proper company that works for your aircraft.
Then you gotta check it by hand, you're done.
All right, we got 2 more nicely done rivets there. So we've got both of our backing plates with the linings riveted on. Everything looks good. Brand new thick brake linings. We'll go ahead and
Would you just change one lining and use the old one? Why not? You'd have uneven pressure, uneven wear. Yep. Good. All right, pretty simple. At least that's lining. I'll do it a lining for you tomorrow morning in class.
before
Okay, master cylinder. Any questions on just simple linings, how the linings are installed on the Cleveland style? Yes, sir.
He had pushed the piston down.
Yep.
What was the pressure causing it to come out? Like, why did you?
So as the lining wears, just like your car, the piston is going to come out and it's going to stay out.
Right.
Okay, so when you get new linings, you got to push that piston back in there, and as long as no person is in the cockpit holding the brakes, it'll go in. So then it goes in, and then make sure nobody touches the brakes so you get it back in, back installed.
Rapco, do they make entire brake assemblies or just?
Yep. Yeah, they're like the Gates. No, like part Gates. Okay, never mind. So if you go to like O'Reilly, you want a good brand, you'd buy Gates. Okay, if you wanted a cheap brand, you'd buy Dorman. So Gates would be like to Cleveland, Rapco is to Cleveland, like Gates is to Chevy, to ACW or whatever. Yep.
I'm still a little confused on leading the system. So are we pressing the brakes or are we pushing down on that piston?
Yeah,
Because brakes is gonna
that's
push the
exactly why I did a play-by-play video, and I'm not gonna show it to you. I'm gonna watch this video. Here's the video in Moodle, and then go out and do it, because that way we're all there. But yes, you're pushing the brakes as someone opens the bleeder. If you're doing top down,
What about when he was pressing the piston?
he's pushing the piston in so that he can get the linings on. If you don't push, your piston comes out like this. Got it? You've got to push that piston in to grab the disc. Okay? Otherwise, it will not go back over the disc because the linings are brand new. Got me?
So he wasn't doing that to lead the system, it was unrelated.
Totally unrelated. You cannot get the backing plate with the linings on back over the wheel unless that piston's in.
So at the shop, they always had us like clamp it.
Yep.
So that the piston doesn't just by gravity or just slide out. Have you ever seen that happen, or is it not that?
Yes, where I've seen it is somebody get in the cockpit working on instrument class and touch the brakes on accident. That's what the class is next week. So while we're doing bleeding brakes, somebody gets in and accidentally pushes the pedal and it's like, whoops. So yes, for our class, if you've got to take the caliper off or to take the linings off, I usually have somebody clamp it so that nobody gets in and pushes it. If I was in a regular shop, we just put a piece of paper up there that says, "Do not touch the brakes." Most of the time, people leave it alone.
Have you ever seen it just like come out though on its own?
Only if it's super lubricated, like well done. But most of the time, it doesn't just ease out on its own. All right, master cylinder. Use it independent brake system used in general aviation, they have compensating ports. I've already passed the master cylinder around. Compensating ports are open when the brakes are off. Open ports allow fluid to flow to and from the reservoir. So you can backfill the system from the caliper, called bottom up. You can actually put fluid starting at the caliper and fill all the way up the master cylinder because it has a compensating port that's open when it's just resting. Ports close when brakes are applied, so the piston pushes down and it will push brake fluid down, restricting the port until you release the brakes. Leaking ports cause the pedal to creep down. Yep.
When it comes to bleeding brakes, I guess I'm a little, not confused, just kind of marveling at how the air stays down there. If it was all water, air would just bubble up and be at the top. Is it because of the viscosity of that 2606 that holds air better?
No, it doesn't stay there actually. If you have air in the system and you park it over in your hanger and just let it sit, it will actually seep to normally towards a bend in the system, or like Piper's notorious for getting in the wings up here and just settling there. It is when you apply your pedal pressure that the air is forced down towards the caliper because it's the weakest link in the system. And so by pushing the pedal, it's forcing that. Fluid's telling, hey, get out of here. And so the air is taking the path of least resistance.
What do you mean by dragging brakes? I've never heard of that.
So when your brakes are gently grabbing your disc, it's common if the master cylinder, boy, we're going to get into scenarios. I haven't even covered bleeding brakes yet, but you will get a dragging brake when it just grabs the disc and holds onto it.
Okay.
Hang with me, Ava, hang with me. You got this. All right, master cylinder. This is a master cylinder, typical master cylinder on a Cessna style, okay? Very simple. Listen, when I give you the lab tomorrow and I tell you to remove a master cylinder, do not remove the whole show. If you go to your O's and P's and they says remove the master cylinder, do not remove the whole shebang. Guess what he's saying? Come up here and there's a little bitty tiny set screw. It's either an Allen or it's the tiniest flat blade. You will remove the set screw by just backing it off 2 revolutions, lefty-loosey. And then you will unscrew the whole top of this once the pin is out from the top of the pedal. The whole top will come out. Where's my master cylinder? Okay, there's a set screw right there. It will unscrew once the pin is out of the pedal. It will unscrew just like this. This is stationary, sorry. Come on. It comes out. Voila. Okay, say it.
Well, bam.
Well, bam. Okay, good. All right, so now we've got the top of it. This is your reservoir. Okay, yes, it does have a spring in it, and yes, the spring only goes one way. The smaller side goes right against there, okay? If you're wondering what the compensating port is right in the middle of that piston. It's got a little bit of movement right there. And then it's got the little groovy right there, so that fluid can go down and right down the center of this. Inside of there is what we infamously call loco seal. Loco seal. There's a cute, teeny tiny baby little washer, O-ring, inside the washer. Today, they have made it so simple that when Job says, man, I need a new loco seal, I have a little bit of fluid creeping past my pedal. They sell the washer with the loco seal already in it for $1.90. Voila. So, You don't even have to think about it as a mechanic. Man, I need a new seal? Great. You buy a Loco seal. It already has an O-ring in there. There it goes. It's all one piece. Now this one's two piece, whatever. The new ones are all together. Okay? So when I ask you, or your DME, ask you, could you remove the master cylinder? You say, sure I can. Hold it. Make sure you get that one out. It should not be that tight. Somebody did, find the last person and yell at them. Okay? Should not be that tight. Just barely loosen it a couple threads and then unscrew that. There it is. You take it to them and they'll say, could you inspect it? Yeah, looks good. And you may have to change the O-rings. That's totally allowed. That's master cylinder inspection.
Ryan, we'd be introducing air in the system by doing that.
Actually, no. Because you're pulling it up above the fluid, and then when you're pushing it back in, you're just pushing it down the fluid. The air's not actually going below into the system down through here. So all this is still full of fluid. That's why you don't remove it.
When we bled the brakes on that, was it Arrow or Archer
Oh.
months ago?
Ugh.
What did you,
Oh.
what were you doing?
Can we not talk about that one right now?
Okay.
That's a whole novel level of maintenance.
Okay.
Piper, there's a reason why I don't give you Piper right off the bat. I want you to like me. When you have other shops call you to do Piper, you know everyone hates them. Yes.
The Allen key we have to remove.
Don't remove, just back off a little bit.
Okay, that was my question.
Yeah,
Just-
don't
just
remove it,
back
otherwise
up.
it goes down into the bottom of the airplane and it's like you're looking for the head of a pencil. Okay, here's the Cessna diagram for all of you interested. Here's the Cessna diagram of the master cylinder. Okay, so what are we gonna pull over here on the top of it? When I say, when the lab says remove the master cylinder, what are you actually removing?
The top.
Don't do it, Johnny. Don't do it. You're gonna make me like dry heave. What are you actually removing? Just the top piece, not this. Think of this as your reservoir. Okay. Okay. This is on Cessna. Piper looks a little different. I get that, and I'll cover Piper in its own special dispensation. Okay. But right now, we're not dealing with that one. Okay. Right now, we're dealing with the master cylinder. Now, this is a baby breakdown of what I just showed you. Here's our piston right here. Here's the O-ring that may need to get changed. Here is the Loco seal. Do not damage the Loco seal. Loco seal is important. But when you're putting this nut back on, you have a spring here. That's the spring that's down there. Okay? If it doesn't have a spring, fire the last mechanic. It should have had a spring in there. Then there's another spring inside here. That spring is to help as it returns when you let up on the pedal for it to refill down the middle of the compensating port. It wants you to have a gap right here, minimum of 40 thousandths. I've run into mechanics that say we put them at 50 thousandths. The manual tells you 40 thousandths. We want 40 thousandths. If you do not put that space when you're torquing, when you torque that nut, if you do not put 40 thousandths and you torque it all the way up, the brakes will push down and never come back. It'll just hold, the pedals will just stay down. Then you will have dragon brakes. Okay? Gotta have a compensation so that the spring will force that piston back down, fluid goes back in, system stays topped up. It's the way it's made. Okay? Alright. Here's what pedals look like on a Cessna. Notice they have master cylinder for the left side, master cylinder for the right side, but they're on opposite sides. The newer Cessnas run both master cylinders on one side. But maybe you're working on an aircraft and you're like, dude, where's the other master cylinder? You may have to move over to the co-pilot side and look. Okay? You're laughing, but I've had people come out and say, they only have one master cylinder. Okay, the left master cylinder is on the co-pilot side on some aircraft, and it controls the whole left side. But they're interconnected with rods right here. Okay? All right, everybody see that? So you may have to back up and look. Oh, master cylinder's on the co-pilot side. They're not both on the pilot side. Yep.
Is this the Loco seal right here? Where's that?
Oh,
It's the
check it. Here's a picture from your, you can go ask him, yeah. Here's a picture from your, Ava, stay with me. I know the lights are up, stay with me, here we go. So, you're the one that asked me to leave lights on, and I feel bad, so.
Why are you outing me? Everyone knows.
Okay, no worries. All right, so, here's our master cylinder and reservoir. As we're pushing brakes, it's pushing down. Now, this spring, here's your loco seal, Mr. Thomas. Thomas, what are you doing there?
I was just,
Okay. All right. All right, so as you're pushing down, it's going to allow fluid to flow right here. Okay, so now it's forced it down. The piston pushes down. This is your piston. But notice it has a little bitty hole right here. So now fluid, as it comes back up, this spring's going to operate with the 40 thousandths gap, and it's going to allow fluid to enter back through the middle of that piston, just enough to maintain a full brake system all the time. Yes or no? Okay, you can give me 30 seconds, and I'll kick you out of here. Any questions on how the master cylinder is doing it? I realize you're going to be able to touch Phil in a minute, so yes, ma'am.
The 40 thousandths, that was with it not compressed, right? Or is
That's
that-
right. You're going to pull the piston down, and you're going to check that gap between right here, and right here.
Okay,
Bam,
so
40
it
thousandths.
has to be 40 thousandths with the pedals compressed.
Well, it's out of the system.
Well, it's simulating that the pedals were.
You would actually be simulating that the pedal is back,
Is
and
back.
the piston's being forced back down because of the piston. So it's already been pushed down, and you're letting up. And you want 40 thousandths.
Its lowest position should be 40 thousandths. It's the
At least 40 thousandths gap between the bottom of this plunger and that piston. Yep. Okay, some of you may have this style, okay? If you don't have a lock ring or a set screw, you may have one of these C-clips. I have only worked on a couple C-clips. Because you lose them. As you try to get back there, you get it over the top, and all of a sudden, ding! Where did it go? Okay, just speaking from experience, the set screws are really nice as long as you don't remove them. But the C-clips, you get them almost into the groove there, and then all of a sudden it's like, ding! And then go find another one, okay? All right. Let's stop. That's enough. You've had enough of me today.